after studying this module, you would be able to derive the family of savings functions, derive the IS function, also derive the LM function, and then understand the dynamics of equilibrium. Right in the beginning, it would be appropriate for us to understand what an IS function is. An IS function gives us the relationship between different rates of interest and the corresponding equilibrium levels of income. The IS function relates the product market equilibrium. It shows us that at each point on the IS function, the product market is in equilibrium such that savings are equal to investment. As we know, the product market depends upon the interplay of forces like the savings, investment, income and consumption. The investment function has an autonomous part which could be described by the equation I is equal to f of A. A stands for autonomous, that is, there is one part of the investment which is exogenous. But apart from this, there is also a savings function, and the savings function is induced, that is, the savings function in the case of the ISLM analysis depends not just upon the level of income but also the rate of interest. In this sense, this is a hybrid savings function that we consider in the case of ISLM analysis. Unlike in Keynesian analysis, where savings function depends only upon level of income, here it depends upon both the level of income as well as the rate of interest. And the equilibrium condition for the product market is saving should be equal to investment. Now, we know that the level of investment is exogenously given, and in the capital market the level of the IS investment function is considered to be fixed. That is, the forces in the capital market do not change during the analysis. That is, the investment function depends upon, or the volume of investment depends upon the rate of interest, but the level of the investment function is constant. Now, for understanding and deriving the IS function, the first step involves the setting up of a family of savings functions. As we have already discussed, the savings function is expressed as S is equal to f of y and r. Therefore, savings depends both on the rate of interest as well as the level of income. Now, this is a peculiar situation because in this case we have to depict the relationship of savings with two variables, but our constraint is that we have to express this relationship within the xy space alone. So, we have to evolve a method for this. The method that we have evolved over here is analogous or similar to the method of partial differentiation, wherein we change one variable and see its impact on the dependent variable, while the other variable is kept fixed, and then seriatim we change the second variable and see its impact on the dependent variable while keeping the first variable constant. So, let us look at how we would derive the family of savings function. In this case, we don't have a single savings function, but we have to derive a family of savings functions. Let us first consider the effect of income on savings. You would notice that in the diagram, if we want to observe the effect of income on savings, then we have to move along the x-axis. When we move along the x-axis, the rate of interest is 0, therefore there is no change in the rate of interest. The savings function depends upon the level of income, therefore we choose some level of income y1. At y1, the savings function starts to emerge from some point on the x-axis. Now, as I have already described, we alternately see the impact of rate of interest and the impact of income on savings. Now we consider the impact of rate of interest. The theory tells us that if the rate of interest increases, then it becomes more attractive for the households to save out of their income, and hence when rate of interest increases, the savings level would also increase. There is a positive relationship therefore between rate of interest and the level of savings. Now, up to a point, if the rate of interest increases, then the households would be incrementally increasing their level of savings. But if the rate of interest increases too much, then obviously the households would not cut down their consumption much more than what they can afford to do. The implication is that for every increment in the rate of interest, for every equal increment in the rate of interest, correspondingly, as the rate of interest goes up, the additional savings that is forthcoming from the household will continuously fall. What is the implication? The implication is that with respect to rate of interest, savings do rise, but they rise at a decreasing rate. Therefore, if we see this relationship in terms of derivatives, it would mean that the first derivative is positive with respect to rate of interest, but the second derivative is negative. Similarly, if we now go back to the level of income, then we have started one savings function from the level which could be described as S1 within brackets Y1, because it refers to the level of income Y1. Then now we go back to income and see its impact. Then on the x-axis we have to move from S1 Y1 to S2 Y2. This describes a new level of income and a new level of savings. Thereafter, we can now increase the rate of interest. When we increase the rate of interest, households increase their level of savings also. The relationship as described earlier is positive, but as the rate of interest keeps increasing, the additional savings due to an increment in the rate of interest would go on decreasing. Hence, we have two parallel savings functions which are positive, they are rising, but they could be described as being concave to the y-axis and asymptotically parallel to the y-axis, because increasingly when the rate of interest goes up, the addition to savings goes on diminishing. Similarly, we could derive after S1 Y1, S2 Y2 and so on, we could have 2, 3, 4 or even 5 savings functions. The sum total or the set of these savings functions are known as a family of savings functions. You would notice now that this is different from an ordinary savings function, which is actually measured on the y-axis and is a linear function. In this case, we have a curvilinear function and we have a set of savings functions, all of whom are parallel to each other and parallel to the y-axis and are rising, but there is a slow decline or a decrease in the rate at which they are rising. So, this is the set of family of savings functions. Now, after this we have to consider another methodological problem. The problem is this, that with the help of a set of savings functions, we have to derive the IS function. How do we do this? There is a method in logic called reductio absurdum. What does it mean? It means that if we reduce an argument or a logic to absurdity, then sometimes we get the solution. So, let us start with a particular rate of interest, call it R5. R5 is a arbitrarily chosen rate of interest which is quite high. And at this high rate of interest, suppose we choose arbitrarily another savings function which corresponds to the income level Y5, that is S5Y5, then at this high rate of interest R5, since we are considering the income to be very high, we would now like to examine and see whether this is logically possible. So, at R5, at a high rate of interest like R5, we now consider what is happening in the capital market. In the capital market, we have already defined that we have a negatively sloped investment function. According to the given level of the investment function, the volume of investment would be low, because at a high rate of interest, the volume of investment could be something like I1. And at this volume of investment, what is required is that in the product market there must be an equilibrium situation. Equilibrium can be attained in the product market when investment is I1 and it is a low level of investment, only when savings are also correspondingly low. So, which is that income level at which the investment would be I1 and the savings would be S1. Obviously, this has to be a low level of income, let us call it Y1. So, therefore, we realize our mistake. Our mistake is that we chose R5 as the rate of interest, and instead of choosing S1 Y1 as the level of savings, the savings function, we have wrongly chosen S5 Y5, which is a high level of income. This is inconsistent. Therefore, our method of reductio absurdum tells us that our choice was wrong, and therefore, according to the logic of the situation, the lower level of the savings function was to be chosen. Therefore, we choose a combination of a high rate of interest R5 which goes along with an equilibrium level of income which is Y1. Now, similarly, we could choose another point on this map, this savings map, and here what we do again, just to prove the point, is to take R1, which is a low rate of interest, and we choose a savings function that is S1 Y1. At S1 Y1, what we would notice is that in the capital market at a low rate of interest like R1, the volume of investment would be I5. I5 is a high volume of investment. When I5 is the volume of investment in the product market, for equilibrium to take place, savings should also be S5. So, S5 would be equal to I5 only if the income level is Y5, and we know that Y5 is a pretty high level of income. Therefore, going back to our family of savings functions, what we would notice is that once again we have done a mistake in choosing the low level of the savings function S1 Y1. Instead, we should have chosen S5 Y5. So, if we consider the 2 points, in the first case we got R5 and it combines with Y1, and in the second case if we choose R1, then it should combine with a level of income which is Y5. Hence, what do we notice? We notice that a high rate of interest is associated with a low level of income, and a low rate of interest is associated with a high level of income. So, if we join these 2 points, that is R5 Y1 with another point, that is R1 Y5, then we arrive at a savings function. As you could now see in the diagram, that the investment saving investment, that is the IS function, is actually downward sloping, and it is relating these 2 points with each other. Now, let us consider the LM function. What is an LM function? An LM function depicts the relationship between different levels of income and the corresponding equilibrium rate of interest. It tells us about money market equilibrium such that on each point there is an equality between money supply and money demand. So, considering the equilibrium condition, we would now like to see how the LM function can be derived. First of all, let us look at the money market. In the money market, with a given level of income, let us say Y1, at this level we have a certain level of money demand due to transactions and precautionary purposes. Now, if we consider this, then the M1 would be M1 Y1, and at M1 Y1 there is a total money demand function which is equal to M1 plus M2. As we know, M2 is downward sloping, and we add up horizontally M1 and M2 and arrive at the total money demand. At the given money demand, there is a given level of money supply which is exogenously determined. It is M bar. Okay. So, M bar intersects with the original money demand function, and then we have a rate of interest, equilibrium rate of interest, which is relatively low. Now, what happens in the product market is that the level of income increases from Y1 to Y2. When this happens, then M1, which is transactions and precautionary demand, also increases correspondingly. The M1 increases from M1 Y1 to M1 Y2, and when this happens, the total money demand increases from MD to MD prime, that is, it goes to a higher level. When it goes to a higher level, it intersects with the money supply function M bar such that the new rate of interest is R2. So, what do we observe? We see that R1 is associated with a lower level of income Y1, and R2, which is the equilibrium, new equilibrium rate of interest, is associated with a higher level of income Y2, and so on. We can go on increasing the level of income that is coming from the product market from Y1 to Y2 to Y3 and so on. But even for our purpose, just 2 points would suffice. That if we take the relationship between R1 and Y1, and similarly we would have a relationship between R5, which is a high rate of interest, and Y5, which is a high level of income. Therefore, you would observe that the LM function is upward sloping. Earlier we have seen that the IS function is downward sloping. Now, if we independently consider the IS function and the LM function, then each one of these functions would tell you about equilibrium respectively only in the product market or in the money market. But our interest is to know what is the level of equilibrium in the entire economy, and this is known as general equilibrium. General equilibrium in the economy leads to the determination of the equilibrium rate of interest on the one hand and the equilibrium level of income on the other hand. So, since there could be infinite points along each of these curves, they would not result in a given general equilibrium condition. So, for establishing the general equilibrium condition, we have to simultaneously consider the IS function and the LM function. So, simply if both the functions are juxtaposed one on the other, then this results in a situation where you have an equilibrium point E. At point E, we have a situation where your equilibrium rate of interest would be, let us say, R3, and your level of income, equilibrium level of income would be Y3. This is a point of general equilibrium or a point of joint determination of rate of interest and level of income. Now, it is possible that an economy is found to be in a state of general equilibrium. We would like to consider a situation where the economy may not be in a state of equilibrium, and this involves what we call the dynamics of equilibrium. For understanding the dynamics of equilibrium, we consider points of disequilibrium. You would notice that there could be 4 points of equilibrium, A, B, C and D, and each of these points are in different regions or segments of the XY space. You would notice that at A, there is an excess supply in the goods market and there is excess supply in the money market as well. Therefore, you would notice that we have written ESG and ESM against point A. At this point, what we can see is that there is an arrow which goes to the left from A and goes to the bottom or downwards from A. Similarly, at point B, we have written EDG and ESM. EDG refers to excess demand in the goods market and ESM refers to excess supply in the money market, and so on. We could look at the other points, that is D and C also. There are respective arrows which tell us the direction in which that particular market will move. The way to understand this is that if we are talking about the IS function, it is with respect to the goods market, and the goods market is being measured on the x-axis. Therefore, the arrow would always be parallel to the x-axis, that is that we would talk of contraction of the income level or expansion of the income level, and therefore it is horizontal. The arrow is horizontal. If we consider the money market, then the arrows would be going downwards or upwards, because the point of disequilibrium would either be above the LM function or it would be below the LM function. So, let us consider one point in the table let us consider point A, which is in region Roman 1. So if you look at the money market, there is excess supply in the money market. Money demand is less than money supply, and this would imply that the rate of interest would fall. At the same point, if you look at the product market, then there is excess supply in the goods market. Aggregate demand is less than aggregate supply, and hence the income would contract. Similarly, we can look at the other points B, C and D. The notable point is that if the economy moves away from equilibrium E and it finds itself at any of these other points A, B, C, D, then there could be two paths that the economy follows. One path would be from A to B and B to E, and the other path would be from D to C and C to E. They look as though it is one S-shaped path, but it isn't one S-shaped path, but two paths which are mirror images of each other. One small question arises: how does the economy move from A to B? For this, we will have to remind ourselves about a little bit of what we call vector algebra. In this situation, you would notice that there are two vectors, one which goes to the left, the other which goes downwards. It would suffice for our purpose to understand that the resultant vector would be in between the horizontal and the vertical vector, and this resultant would lead to a situation where the forces bring the economy from A to B, and similarly at other points. Now, let us now summarize what we have done. First of all, we have derived a family of savings functions because the savings function depends upon both rate of interest as well as level of income. We have then derived an IS function with the help of the savings function and the equilibrium in the product market through the capital market. We have derived the LM function, which depicts the relationship between different levels of income and the equilibrium rate of interest. The LM function, as we have seen, shows the equilibrium in the money market, and then we have put together the IS function and the LM function so as to obtain general equilibrium in the economy. Now, finally, we have seen how disequilibrium takes place in the economy, and we have arrived at the conclusion that there could be two paths from A to B to E and from D to C to E, and finally the economy would arrive at the general equilibrium level E.